Hi, today we are going to see about the basic concepts of electrical machines. The role of electrical machines in the day to day life is more when compared to the other kinds of electrical apparatus. So it starts from pumping the water from borewell to mixers, grinders. So we are using it in the industrial and commercial applications. So before going to study the basic concepts and working principle of the electrical machines, we should know some basic concepts starting from the magnetic circuits. Here I give you the overview of electrical magnetic circuits. So magnetic circuits in that, so we should know the concepts of electrical machines and what it is doing in the circuit and what kinds of operations we are performing through the electrical machines and review of the magnetic circuits like the basic definitions of mmf, flux, reluctance and inductance, and series and parallel magnetic circuits like series and parallel electrical circuits, magnetic versus electrical circuits, and statically and dynamically induced EMFs. This is the most important topics in the magnetic circuits. And hysteresis and electrical eddy current losses which are presented in the magnetic circuits is much important. And finally, pH curve and the AC operation of single and multiple exit systems is needed to understand the working principle of all kinds of electrical machines. So now we are going to review the basic concepts of magnetic circuits. Basically, we have two types of magnets. One is permanent magnet and another one is a electromagnet. Permanent magnets are always be the magnet, so it offers two poles. One is north pole and another one is a south pole. And the right side images shows you the electromagnets which can act as a magnet when you are energizing the coil which is placed on the core. So here the core is surrounded by a coil. So when you are exciting the coil with a DC supply or AC supply, so that will create a magnetic field. So that magnetic field is utilized for the conversion of one of the energies into another. For example, motors. So motors are converting electrical energy into mechanical energy. So that the magnetic flux produced by the windings plays the role in developing the EMFs and the torque to rotate the rotor. So magnetic circuits are made up of one or two closed loop paths. So this fluxes is usually generated by the permanent magnets or electromagnets. As we discussed in the earlier slides, there are two magnets. Permanent magnet and electromagnets are used to perform the task in the electrical machines. And ferromagnetic materials are used to make the magnetic circuits and magnetic paths in order to provide a low reluctance path for the magnetic flux lines. And this is here a image is shown. So here this image is consisting of a coil which has n number of turns and a core. It is a square shaped core. A coil is wounded on a limb of this core. So you see that this coil is energized by the current I, and this I is flowing through the coil. So this develops a magnetic flux lines. So that flux lines are travel through the core provided over the coil and reaches the coil. So here it starts the moving and it is flowing through the core. Finally, it reaches the north pole. So this is called a magnetic circuit. This is called as a magnetic circuit. So it is consisting of a coil and a ferromagnetic core. So when the electric current is passes through this coil, so that will develop some magnetic fields. So that magnetic strength is depends on the magnitude of current and the magnetic number of turns in the coil. So here we need to know some analysis of these magnetic circuits. And here flux density in the material B is the ratio of flux by area. So this is called flux density. So that flux density decides the force and the EMF generated in the DC generators. And this is the definition for the flux. Flux pi is equal to mmf divided by reluctance. So that reluctance is like the resistance in a electric circuit. It opposes the flow of fluxes which passes through the core. So when you are making the core with low reluctance material, there may be a more number of fluxes may passes through the particular magnetic path. And here you see that this is the best example for the magnetic circuits. Now you can see these kinds of RO solenoid in RO water purifiers. Their role is it is cut offing the water inlet, and it is automatically when it is energized it will open the path for the water. So that is the main role it is performing in the RO. So here there is a coil and there is a solenoid within this coil. So this is the watt. So when you are energizing this coil, so it will create the magnetic field and it pull the plunger which is placed inside the solenoid. So automatically the water inletted into this valve is passed through the output side. So you can get the water flow. And when these magnets or when this coil is demagnetized by deactivating the supply given to the magnetic circuits or given to the valve, automatically the plunger which is supported by the spring tensions will move downward and it closes the holes and it stops the water. So this is the main important applications of this is one of the application of our magnetic circuits. And this is the plunger inlet structure. So here water is inletted and this is the moving plunger. It is supported by the spring tension. And when this coil is energized, automatically the plunger is moving from the bottom to the upward position. So that is due to the magnetic force which is attracting the plunger. And once the supply to this coil is demagnetized, automatically the branches will move down and it closes the flow of water. So this is the basic principle of water. And here I shown you the images, animation of the solenoid valve working. So here you see that the switch, when the switch is closed, automatically the coil is energized by the input source. So that moves the plunger, that pulls the plunger upward, and that create a path for the water flow and liquid. And when the coil is demagnetized by switch offing the switch, automatically the spring tensions will boost the plunger downward, and it creates the closed path for the water flow. So this is the basic operation of our solenoid. And we need to know some basic definitions of magnetic circuits. So magnetic flux, the magnetic flux lines of force produced by the magnet is called magnetic flux. And here you can see the images. So there is a two poles in the image. One is north pole and another one is a south. So normally the flux is travel from the north pole to south pole as like the image. And you can see that there is a flux movement from north pole to south pole, but there is no interaction with the flux. The fluxes are traveled with the uniform air gap. So this is the structure and this is the way of flowing the fluxes from north pole to south pole. And flux density, as we already said, flux density is defined as the ratio of flux by area, or we can define it as a flux passing per unit of area through a plane at right angles to the flux. So it is called as a flux density. And magnetomotive force. So this is the force created by the magnetic circuits. The current flowing in an electric circuit is due to the existence of motive electromotive force. Similarly to the magnetomotive force, MMF is required to drive the magnetic flux in the magnetic circuits. The magnetic fluxes which sets up the magnetic flux in the magnetic circuits is called as magnetomotive force. And here this MMF produced by a coil is defined as N into I. This is the formula for finding the magnetomotive force of a magnetic circuit. And here this N indicates the number of turns and I indicates the current flowing through